So normally I'm always so if I'm too loud, just tell me that. Pieces, enough seats. So my name is Eric. I work at Extrahop, and I want to have a conversation about how to get attackers in your network. Now, to do so, I really need to explain a little bit of what kind of tools are out there, because when an attacker comes in, right, when they get into your environment, there are a lot of other tools, right? So where do we fit in? So this is what Gartner calls the sub-credibility triad. And sub-credibility triad really says, listen, we know at a certain point somebody will get it, right? And to get that visibility inside of your organization, you really need three things. That's SIEM, and EDR, and NDR. Now, SIEM takes information from logs, right? It uses those logs PLCs, and EDR is installed on the endpoint and looks at the endpoint and all the information it gets from there. Now, NDR uses a different source. It uses the network as a data source. Now, you can imagine that when you guys use your laptop and you're communicating, there's a lot of data going over the network. Right? If you're now able to use that network traffic to be able to detect, not only based on signatures, because that's really simple, but really based on behavior. We use AI to, and I know I'm going to use AI as a high term, but just understand that AI, being able to really use it, we need a ton of data. Right? And if you look at the network, there's a ton of data going on, so you're really good and able to see unusual behavior that devices never show. Now, most companies will probably have seen NDR. With NDR, because we are taking a copy of the network, it is the ground truth to everything that happens. Right? It doesn't need any agents. It's ageless, so it's really covert. Nobody's able to see that you're listening in. That also means that it's really difficult to detect. And nowadays, unfortunately, for the cyber criminals, they have a big problem with SIEM and the reason is they don't like to be detected. Right? So they have started to disable SIEM, which happens really more logs, right? But nowadays also EDR. And if you want to Google, there's somebody that calls himself Spyboy on the internet, and he's selling this tool which can just disable all the EDR vendors, which is really annoying. I'm not saying you don't need logs and EDR anymore, no, absolutely not. But we need to realize the fact that these things can be disabled. And what then happens is, you have this intelligent gap. Because a normal SOC will use SIEM, will use EDR to be able to protect this environment. Now, if those tools get disabled, or those systems get disabled, there's a big indemnity. The hackers can just move through your environment without you even noticing it. They target unmanaged devices, IoT devices, medical environment, MRI scans, but nowadays also VPN servers. Unfortunately, there's some vulnerabilities which detect this ransomware group, always using to get in via VPN servers. That's not right. There's not a lot of security problem, right? So they're able to get inside of your organization without doing this. 70% of the cases they have done that when it comes to breach. Try to evade your defenses, disable EDR based methods. And most of the data that you have inside the organization is encrypted. So when I say we use the network as a data source, most of the traffic is encrypted. And what we do, we can decrypt that. And I'll give you an example of that later on. But by decrypting the traffic, if it's TLS traffic, SSL traffic, or if it's TLS 1 and 3, can be the perfect source for a secret to be able to decrypt that. or by integrating with a domain controller to get that key to be able to interpret that, you're able to see exactly what they're doing there. Because hackers love to ignore the traffic, because they really want to go unnoticed in your environment. An example is, for instance, Brit Nightmare. They used SMB version 3 to just move around within the organization. Nobody saw them because they were heavily encrypted traffic. So by seeing that again, you get back that result. Now, if you look at a typical attack, right? When they get in, initial intrusion, and until the breach, and this is ransomware. And why ransomware? Because there's supply chain attacks, there's nation states that do really sophisticated attacks. Really, the problem that we face the most are really ransomware tools. Those are the most annoying guys on the internet that make most companies' lives really difficult. So if you take ransomware as an example, from that initial intrusion they do, the first thing they do when they disable EDR and logging, and which they will, because it's an automatic script that most of the time just runs and just disables that. The first thing they'll do is try to see if they can set up some sort of command and control system. The reason is, if they came in via vulnerability, right, you might test that vulnerability, and their entry point to that environment is gone. So they build a command and control system. That command and control system is going to go over the network, communicate to the internet, and that's the first detection that we'll do. We'll see that unusual behavior from that device all of a sudden communicating to the internet via HTTP or DNS, whatever kind of tunnel they use. Next thing they do, and I'm talking not as a hacker, but what a hacker would do, right? Next thing they do is they don't know where they got into. They probably know the company name, but they don't know your resources, what they can get to really be able to target you and do more damage. So they'll start doing scans on network, right? They scan the TCP scan or use Bloodhound to do domain enumerations. See what kind of file shares you have, because if they want to encrypt things, they need to know what kind of shares you have. Bam, 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 and you get all these detections. The reason you want to see that is because you want to stop them before they get to the point that it starts hurting, right? Because they'll lose lateral movement to go to other devices in your environment. And then, and that's the point that it's really too late, they'll exfiltrate your data. Maybe they do some data staging where you can see that we get a detection. But really, when the data exfiltration happens, you're too late, right? But you have a lot of other detections beforehand to be able to stop that, to act manually or use our integrations to, for instance, tell your firewall to kill that command and control session, or automatically put a device in quarantine if there's still an EDR agent on it, or if you have a network access control system, just kill that connection, put that device off of the network, and be able to remediate afterwards. Now, how this solution works, and I'll give you a demo in a bit, but how this solution works is that we need a coupling agreement, right? So we don't use agents, we just passively listening. That also means when you decrypt, there's no delay of that network because it's just a copy. We use the copy to decrypt that. That data feed can come from your cloud environment, Azure, AWS, Google. It can also be a data center, or maybe an office, or a remote location. It really doesn't matter. As long as we get that copy of the network traffic and we see everything, then we're able to analyze it. And the power is really in that artificial intelligence that looks at the environment, being able to detect the unknown vulnerabilities, right? when Log4j happens, everybody knew about it. But we were able to detect it beforehand because we saw that those devices acting really strange. With Log4j, for instance, the first initial attack was using HTTP to ask the server, hey, set up an outlet connection to the outside world, to my server on the internet, right? Now the first HTTP request was pretty common, right? But then when that server all of a sudden started communicating via LDAP to the internet, that was weird, right? We detected that at the time. We didn't know what it was in the sense of, we didn't call it Log4j, we just said, hey, unusual traffic based on LDAP going towards the internet. You should really investigate this. So being able to detect that based on behavior, our customers were able to stop it before it even came to the point where it really started working. Now another thing that we do with this solution is, it is really good to look at all that data and then the detections based on that. But The problem comes afterwards. If you now have a detection, you stopped it, you really want to investigate, okay, our Extrahop detected that, but what else did they touch, right? We keep a history of 90 days of all those transactions, all those records. So 90 days, you have a record of everything that happened. So let's say they attacked you yesterday, you'll be able to go back in time, see what happened, and then be able to see if they touched something else, right? We detected this, but what else did they touch? Do I need to worry about something else? Yes or no, right? From compliance point of view, this is really good. From a forensic point of view, right? When you're working in a SOC and you need to investigate this, now all of a sudden you don't have to guess what happened, you actually know what happens. And that is really the power of what this solution will do. Demo time. If my internet connection still works, because it's not that stable at the moment. Let's see. Any questions in the meantime? So you will see I tested it all day long. It works. And now when we need it, it's not connected. So what I want to show you is that when you see the detections, you actually get a lot of information from it. Because it is not just having the detections, but as soon as you get a detection, that's interesting. I assume that it works. Yeah, I got it. So, okay. I normally use this Drupal exploit here to explain what it does. Yeah. So this is our marketing team asking, hey, you want to chat with us? You want to buy this product? No, not at the moment. Later on, maybe, guys. So there's a lot of things that we can see in this product. But one of the things is that, let me just put my timer back on where I am on time. So one of the things I can show you is all the detections that happen, right? Now, when you get a detection, like I said, when you get early stage of an attack, right? That ransomware detection, you can do that. You're too late, right? No use, right? The problem is already there. So this Drupal exploit gives you a good example of how our solution works. Was that a question? No. So we have our vendor on the internet, right? We have a victim, which is a Drupal server. It's a server on our internal information site. So what you see here is this offender targeted our Drupal server with a vulnerability. Now, we see the time that it happens, but I really want to investigate, right? This is what somebody in the SOC would do. If I go to the detection details, one of the most important things we need to know is, okay, this happens, right? But what happened before that time and what happened after? Right. Really what I want to do is, here I would like to stop it. Maybe I didn't know here, right? Because they were doing scans on the internet towards my Drupal server, and I'll show you detection later on. But they were scanning, they were still trying, hey, is there something interesting that we can use here? Then they find an exploit on my Drupal server, and they misuse this. This is a signature-based detection, by the way. The first one is a machine learning-based detection, or AI detection, whatever you want to call it. Now, why this is important is we automatically correlate all these detections for you. So you don't have to see, hey, what happened before love. We'll do that here for you. Now, in normal hack, like I said, we'll do a command and control session, right? We'll set it up because you never know when that vulnerability. So the outbound suspicious connection, to the suspicious IP address, that is command and control session. Again, right? When I'm on the network, I don't know anything, so I want to know what's out there, right? I do a scan on the network. Then I find something interesting, do lateral movements. Then I do some SMB6 brute force and some other crypto mine. The point is, here you are with warning. Here you can take action. This doesn't happen anymore. That is the goal. You want to see the early stage of the attack. Now, from a SOC perspective, you need to understand that these guys, they're looking at logs and stuff like that, which is really a lot of work. There's a lot of stuff coming out of a scene. This will actually help them to do better detections. So how I see really how you should use that SOC visibility triad is EDR and NDR are your most important sensors. They all feed the scene with these kind of detections for the scene to actually do what it needs to correlate instead of just ingesting a lot of logs and don't know what to do about it. So when you have a SOC engineer, instead of now having to guess what happens, we actually pull the records that we have with the actual payload so they can investigate what happens. Right? We automatically pull that into here so they can investigate. If it's a junior SOC engineer or even I, right, certain vulnerabilities I've never heard of and I don't know what they are, it actually shows you what it is, right? The attack background, mitigation options, and references to MITRE, CVE, OWASP, whatever kind of stuff they want to read. Like I said, this is a signature-based detection. The most important thing is our machine learning-based detections. So here, the first one was the web directory scan. So the web directory scan was this person on the internet trying to figure out, is there anything useful here, right? Now what you see here, I'm trying to zoom in a little bit, is they did a scan based on HTTP. This is just protocol, right? And 404 means error, pretty much. So what you see here is that expected value, and this is our demo environment, so it's going to be 0. In a live environment, this can be 100, right? The point is, in a 1 hour period, we see a lot of deviation, right? Which can be tied to malicious activity. This is why the detection comes, right? It helps you to identify, we need to look at it. An interesting thing is, if you see that, right, 37, the risk score, it's pretty low. The risk score says, what is the probability that this is an attack? Right? This can be anything. This can also be somebody just scanning what kind of products you have on your website, right? Really doesn't say, so the probability that this is something really malicious, we don't know, right? That other one, that vulnerability that they found, yeah, that's going to be a high risk score. Some companies or customers will ask me, hey Eric, do I now need to look at those high risk scores? Most of the times, no, I would definitely look at the low ones because these are your early signals that you need to investigate what it is before you get something that is with a high risk score, like data exfiltration, because then you're too late, right? So when it's cooled down, again, we have these related detections. And as you can see, by the way, the offender, which was an IP address on the internet, was the offender. The victim was the Drupal server. That victim role changed because now the hackers are starting to use this Drupal server as a basis of their attack, right? So the role changes. Now all of a sudden the Drupal server starts being the offender on the on the internal networks. So what is really important is that we try to give the SOC engineer all the information that they need to investigate. So one of the things you see here is the server that it happened on, right? And I'll show you what this magnifying glass does, but it takes you to a reference. Every time we have information, there's a magnifying glass to get more information. So you see all the URIs that have been scanned, which is really valuable for them to be able to investigate. Let's see this code a bit more. So another thing is, we see different states of right? The 404 was an error. There's other errors there, 403, 405. I'll show you what these magnifying glasses do, right? So I know about the 404s. I saw all the websites or the URIs that they scanned. But I can actually now investigate, what is that 403? If I click on it, it takes me to the actual records. And these are really vital for a SOC. Because when a company gets hacked, right, you want to know exactly what they did. This is the actual history. It's like I'm old, right? This is like the VCR, the video recorder on the network. You just rewind and look back in time to see what happens. These records show you, for instance, the timestamp, the record type, which is HTTP, the remote, the IP address, client port, server. It shows you what kind of methods is being used. Now this is all technical, and for SOC people, this is really a lot of interesting information. URI, user agents. From the user agent, sometimes you get a lot of interesting information on maybe it's a malicious user agent already known for doing things. like a Kali Linux user agent, right? It shows a lot of information to be able to identify. This is something I need to do. Now, another thing you see here is the red camera. So on the internet, we have these threat intelligence feeds, which pretty much say, hey, this IP address is known for doing bad stuff on the internet. Right? So if I click on it, there we go. It shows me, yeah, this IP address we saw on the internet was already known for doing bad stuff. It's on the IP malware list. You can use our threat intelligence, but if you have a better one, right, or if you want to combine threat intelligence, then this is really helpful. And threat intelligence is always going to be bad, because you can imagine that when an IP address on the internet is known, or domain is known for doing bad things, it already did bad things. So they already did it. So it takes some time before these IP addresses domains get publicized. We can use that information. So what we do is that threat intelligence, all these records that we have, it actually goes a couple of times a day. It goes back in time, 7 days, to see, hey, we have an update from the threat intelligence. Let's see if we got hit in the past with these IP addresses, which we did not know at that time, but we now know that these are malicious. So it helps to give you more context about, hey, this threat intelligence is great, but now I can actually use it also in the past to see if something happens. This, by the way, is for HTTP, but you can imagine there's so much protocols, languages on the network that is broken. All these different protocols we support, and we're able to store for 90 days, so you know exactly what happens. We even have a capability, because these are what we call records, to actually go to the actual packet. So if I click on this transaction, on this icon here, it takes me to raw data. And that raw data can be extracted and downloaded as a pico file, can be analyzed in your Wireshark, whatever kind of tool you like. It can also be used to provide to the authority to say, hey, listen, we got breached, or we got hacked, or hopefully not breached. We got hacked, somebody got into our environment. We have the raw data as a proof, but as you can see, they didn't extradite or get into our privacy sensitive corporate data. Right? Is the actual proof what happens. Let me go back one step. So, as you can imagine, by looking at that network all day long, we can give you the real-time detections, right? We can have the record of what happens, we're able to investigate. We can use the automatic remediation by integrating with other tools, other security tools to take action, because we only listen in to the network. We don't take action ourselves, we use other tools that can do that. But because we look at a network, there's a whole lot of other information that we know. Right? I can go, for instance, to this Google server, and I know exactly what it does. Right? I can see what kind of protocols it's using as a server, as a client. I know its IP address, which user are using it, and that's only by listening in on a network. We can see the authentication, right, on CIFS and NTM. We know exactly what user is using that. And the MAC address. But what is really cool, and that's, so my background is I was a network engineer at Singapore, doing a lot of network segmentation for customers, right? And network segmentation, nowadays they say, oh, if you want to have zero trust, then you need to have network segmentation. Not really, but zero trust is a mindset, right? Not trusting anything. So if you don't trust anything, why would every device on the network be able to communicate to each other? Might as well split it up in different groups, right? Servers, clients, right? So it is really helping your zero trust mindset in that sense, right? Helping your organization to get a better security posture. But the problem with that is, and that's what I've been facing a lot during my network engineering times, is that when you want to split up the network in different segments, then these devices all communicate to each other. If you now put them in different segments and put a firewall in between, and you stop everything from communicating, you're pretty much going to break things. During my networking times, I need to do a lot of these changes on the network. The problem was that these changes could only be done during the evening or the weekends, right? We did a change. Fortunately, we always had a rollback plan, as we call it. Changes didn't always went well, because I asked the server guy, what does your server do? He said, well, they're a bit of this and that, right? Then we did the change, guess what? It delivered more than he said. So I do the rollback plan, right? Next week when he's coming, because he wasn't there during the weekend during the right? Next week or the next day when he was back in the office, I said, hey, something went wrong. He said, okay, he said, well, let me look at it, right? Oh, yeah, he did a little bit more. Now, this Drupal server, I can see here the gearboxes. What I can do, because we look at the network traffic all day, I know, when it loads by the way, I know exactly what it's communicating with. And there's a timestamp there, where is it? Somewhere, oh, here we go, over there, right? For what time I'm now looking at. I can look at it from a week's point of view, a month's point of view, a year's point of view. I know exactly what it's communicating on. So if you want to do network segmentation, this is really helpful to know exactly where this stuff comes. And to change your firewall in such a way that when you do the change, you don't have to use your rollback plan. It actually doesn't work. Another thing, and I got 4 more minutes, and I'm going to stop, is because we look at that network all day long, I can tell you a lot of other stuff. And the most important one is, because we have a different dashboards with a lot of information, is this SMB negotiations. I can tell you, do a lot of development, POCs, whatever you want to call it. So we put our sensors in the customer environment, and then we see a lot of stuff. I have never done a POC that I didn't find SMB version 1. It's really sad, because Microsoft has said for years now, this is not secure, you need to get rid of it. Unfortunately, there's a lot of legacy devices still in the customer environment that they cannot get rid of, but you need to know about this. Because SMB version 1, hackers, and especially the ransomware groups, love it. It's so easy to misuse. They say, thank you very much. We're going to encrypt everything for you. So it also gives you visibility on what kind of protocols or servers are in your environment that you really don't want to have. Like the Log4j, the biggest problem we had is what kind of servers are actually vulnerable to that. What are my web servers? We can identify that just based on the assets that we see on the network. We're able to say, hey, this is HTTP data, right? I have 55 servers. And if I click on it, I get a complete list of all these servers. Here we go. So now I know exactly what I need to look at and which servers I need to identify to be able to see, or which ones there are, which I need to go to and see, hey, are these vulnerable? We cannot see which one is vulnerable, right? But we can identify which ones we have that we need to look at and see if we need to patch them. So this helped a lot of our customers when that Log4j vulnerability came out. They know exactly which servers, they knew exactly if they got hit, they were able to investigate based on the records that we had. Hey, did they try something? It's really like a big brother on the network, right? Looking at everything and just having an eye on your own information and giving that information to you when you need that. So I'm going to round up. We have a couple of more minutes, so if anybody has questions, this is the time to ask. Well, maybe it's always one that needs to go first now. Then I want to say, I'll be downstairs at the booth. If you want to have more information, just come by. We can have a chat. I'll be on the main streets the last week of the day, so try to have a little bit of fun there with you guys as well. So thank you for your time, and have a nice day and enjoy it today.